Fruit flies look nothing like humans, but they respond to movements in their environment in much the same way as people, which is why Dmitry Shklovsky and Shinya Takamura from the Howard Hughes Medical Institute have spent the past 4 years studying their brain circuitry.
We would like to understand how a human brain works, but we focus instead on simpler brains, like those of fruit flies, because we think that those brains operate based on the same principles as the human ones.
Neuroscientist Shklovsky and his team have produced a colour-coded three-dimensional map of the neurons in the fruit fly's optic medulla, the part of the brain which processes signals sent from the insect's eyes. It was a time-consuming process that began with a frozen fruit fly brain and a high-tech slicing machine.
To map out those wires, we slice the fly brain, like you would say a prosciutto, into very, very thin sections, and then photograph each section under electron microscope, and then had computers trace those wires from photograph to photograph to reconstruct their shape like it is in the real brain.
In all, 200,000 images were processed from 2,800 brain slices, producing a complete three-dimensional image of a complex system of neurons and their connections, each 1,000 times thinner than a human hair.
I think this network structure is the basis to understand what's going on, what the neuron does.
And researchers think they can eventually apply the lessons learned about fruit fly brain circuitry to humans, creating models for future generations to develop sophisticated machines that can think, and maps for medical scientists to develop treatments for neurological diseases like Alzheimer's and Parkinson's.
I am convinced that to understand how to cure neurological diseases, we need to understand the operation of a healthy brain first. And my dream is that by understanding how the brain computes, we will be able to help cure those diseases.
But there's a long way to go. Both scientists acknowledge they're only just scratching the surface.